In our lesson today, we're going to investigate proportional and non-proportional relationships. Okay, we're going to tie together our work with rates and unit rates and see how that can help us identify a proportional or a non-proportional relationship. So in our first question, we're told that Mrs. Cochran is planning a pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Complete the table to determine the cost for different numbers of pizzas ordered. Okay, so looking at the table, we can see that one pizza cost $8. Okay, and again, it's $8 per pizza, so two pizzas would cost $16. Three pizzas would cost $24. Four pizzas would be $32, and five pizzas would be $40. Okay, what I want to do is try to figure out if the relationship between the cost and the number of pizzas ordered is a proportional or a non-proportional relationship. In order to do that, I'm going to look at each ratio and I'm going to take the ratios and simplify them down to a unit rate. Notice how we're going to set up our ratios. We're going to set them up as dollars to pizzas, cost per pizza, okay? So looking at my table, okay, in my first set of data here, I see that it's $8 for one pizza. So my first rate is going to be 8 over 1. Okay, and this is already a unit rate because the denominator is a 1. It's $8 for one pizza. Okay, so I'm going to move on to the second set of data from the table where it says it's $16 for two pizzas. 16 over 2, $16 for two pizzas. I'm going to make this a unit rate by dividing both numbers by 2. And when I do that, I'm going to get a unit rate of 8 over 1, $8 per pizza. Okay, next set of data, it was 24 over 3, $24 for three pizzas. Make that a unit rate, divide each number by 3. And again, I'm going to get 8 over 1. Next set of data, it's $32 for 4 pizzas. Make it a unit rate, divide each number by 4. And I'm going to get 8 over 1 again. Finally, the last rate is going to say 40 over 5. And make it a unit rate, divide each number by 5. And I'm again going to get 8 over 1. Okay. So looking here, okay, I can see everything simplified down to 8 over 1, which in words means $8 per pizza. So when it asks in question B, what is the unit rate associated with the ratios above? All right, the unit rate is $8 per pizza. Okay, remember that a unit rate needs to include units, so that's why it says $8 per pizza. All right. What do you notice about the simplified ratios? When I look at each unit rate here, everything was simplified down to 8 over 1. So what do I notice about the simplified ratios? They are equal. Okay, because of this fact, because they are equal, the cost and the number of pizzas ordered represents a proportional relationship. When all of the rates simplify down to the same unit rate, we call that a proportional relationship. So we just saw that the cost and the number of pizzas ordered in the last example was a proportional relationship. In the box, this is what our definition is for a proportional relationship. Two quantities have a proportional relationship or are called proportional if their ratio is always the same constant. In equation form, y divided by x equals k. Some number divided by another number will always equal k, which is some constant. Go ahead and circle that equation. That's going to be very important. Again, said another way, y divided by x is equal to some constant number. This constant k is called the constant of proportionality. All right. So in question D, when it says, what is the constant of proportionality for question number 1? Well, if we go back up and look at what happened here, when I did my division in each case, 16 divided by 2 was 8 over 1. 24 divided by 3 was 8 over 1. 32 divided by 4 was 8 over 1, etc. Everything simplified down to 8 over 1. So my constant of proportionality in this example is going to be 8 over 1, Or you can just call that 8 because 8 divided by 1 is 8. All right, the constant of proportionality K is 8 over 1. Notice that the unit rate contains labels. Back up above when we mentioned the unit rate, we said that the unit rate was $8 per pizza. The unit rate includes units. But when I'm talking about the constant of proportionality, the constant of proportionality, K, does not have units or labels. K is 8 over 1 or just 8. All right. Now, this is for a proportional relationship. The relationship is called non-proportional if the ratio between the two quantities is not constant. So back up here, if I simplified down to my unit rates, but I didn't get the same number every time, I would call this relationship non-proportional. In example number 2, we're told that a computer programmer charges customers per line of code written. In the table, we can see 50 lines of code would be $1,000, 100 lines of code would be $2,000, 150 lines would be $3,000, 200 lines of code would be $4,000. We need to determine if the relationship between the cost and the lines of code is a proportional or a non-proportional relationship. So again, we're going to do that by writing the ratios of cost to lines of code in simplest form, as in their unit rates. So let's set this up again. We're going to do cost, or the dollars, to the lines of code. So let's set up our ratios in this way. Our first ratio, looking at the table, it was $1,000 for 50 lines of code. $1,000 for 50 lines of code. For the unit rate, we need to know how much it is for just one line. So we'll divide each number by 50, and that is going to give us a ratio of 20 over 1. 1,000 divided by 50 is 20. Next ratio, it was $2,000, and that was for 100 lines of code. Make it a unit rate by dividing each number by 100, and that's going to give us 20 over 1. Third rate is going to be 3,000 over 150, $3,000 for 150 lines of code. Make it a unit rate by dividing each number by 150, and that gives us 20 over 1. And then the last rate from the table, it was $4,000 for 200 lines of code. Divide each number by 200 to get to the unit rate, and that again gives you 20 over 1. So question B asks, is there a proportional relationship between the cost and the lines of code? Well, in order to determine that, I'm going to look at my unit rates. And when I look at the unit rate for each example, I notice that they're all the same. So yes, there is a proportional relationship between the cost and the lines of code. Explain your answer. Since all of these unit rates are the same, I can say that there is a constant unit rate. There is a constant unit rate. All of the unit rates were the same when I simplified everything down. Since this is a proportional relationship, I'm going to state the unit rate and the constant of proportionality. The unit rate in this example, remember, it includes the units. What do each of these represent? 20 over 1? Well, it's $20 per line of code. So the unit rate is $20 per line. It was $20 per line of code. The constant of proportionality, remember, that's our variable K. That's that constant that we got every time we simplified it down. So K in each example is 20 over 1, or again, we can just call that 20, okay? That is the constant value that we got each time we simplified our ratios. Example 3 says, for a local baseball game, Uptown Tickets charges $7 per ticket, plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? All right, so in the table, I have all of my data. One ticket's $10, two tickets is $17, three tickets is $24, and four tickets is $31. Let's determine if we have a proportional relationship, again, by looking at those unit rates. So in letter A, we're going to write the ratios of cost to tickets orders in simplest form, again, as a unit rate. Cost, or dollars per ticket. That's what we're going to do to set up our rates. Looking at our data for the first set, I can see the cost was $10 and that was for one ticket. That's already a unit rate because my denominator is 1. So I'm going to move on to the next set of data. It was $17 for 2 tickets. To get a unit rate, I'm going to have to divide each number by 2. 17 divided by 2, that's going to be 8 and 5/10. Since this is money, I'll put an extra 0 on there, $8.50 per ticket. Third set of data, it was $24 for 3 tickets. To get a unit rate, I'm going to divide each number by 3, and that's going to give me a rate of 8/1. Finally, my last set, it was $31 for 4 tickets. Divide each number by 4, and that's going to give me 7 and 75 hundredths/1. B asks, is there a proportional relationship between the cost and the tickets ordered? To determine that, look at your unit rates. When I look at the unit rates in this example, notice that they're all different. I didn't get the same unit rate, okay? That means that there is not a proportional relationship. This is called non-proportional. The reason why it's non-proportional is because the unit rates are different. There is not a constant unit rate. Since all of the unit rates were different, I can say that there is not a constant unit rate. All right. In letter C, it says to state the unit rate and the constant of proportionality. Well, in this example, because all of these were different values, the unit rate does not exist. So I'm going to write n/a, meaning it's not applicable. I can't give you a unit rate because they were all different each time I simplified. So there is no unit rate. State the constant of proportionality. Well, again, since all of these were different values, there isn't a constant of proportionality. And again, I'm going to write NA. It was not applicable. For a non-proportional relationship, you cannot have a unit rate or a constant of proportionality. In example number 4, the table below shows the hourly charge to rent a bicycle at Supercycle's bicycle store. Find the unit rate and the constant of proportionality K. All right, so looking at our table, we can see the number of hours that you can rent the bicycle and how much it would cost to rent the bicycle for that number of hours. So what we're going to do to see what kind of a relationship exists is look at the ratios rather of dollars to hours that we've rented the bicycle. So we're going to set it up as dollars per hour in this example. From our table, we can see that 2 hours is $24, $24 for 2 hours. Let's make it a unit rate by dividing each number by 2, and we would get 12/1. Next rate, it was $36 for 3 hours. Divide each number by 3 to get the unit rate, and that again is going to be 12/1. Next rate, it was $48 for 4 hours. And if we divide each number by 4, that gets us to a unit rate, 12/1. Last set of data from the table, $60 for 5 hours. Divide each number by 5, and we end up with 12/1. Okay, so if I look at my unit rates in each example, notice that they're all the same. That means the relationship between the cost and the hours rented is a proportional relationship. So now I can state the unit rate and the constant of proportionality. The unit rate, remember, includes units. 12/1 in this case means $12 per hour. The unit rate is $12 per hour. The constant of proportionality K in this example, every time we simplified down to the unit rate, we got 12/1, or we can just call it 12. In example 5, we have another bicycle shop. This one's called Pedal Rentals, and the table shows the cost for renting their bicycles for a certain number of hours. So $4 for a half hour, $8 for an hour, etc. Once again, we need to determine what kind of a relationship exists by setting up the ratios and then simplifying everything down to their unit rate. So once again, we're going to set this up as dollars to hours. And looking at our first set of data, for a half hour, it's $4. So for the cost, it was $4 rather, and that was for a half of an hour. Notice again, this is a complex fraction. We have a fraction within a fraction. We need to turn this into a unit rate. To scale from a half hour to a full hour, we would just multiply by 2. So I can do the same thing to the 4. 4 times 2, our unit rate is going to be 8/1. Next rate from the table, an hour is $8. $8 for 1 hour. That's already a unit rate. Your denominator is a 1. So now we can look at the next set of data. It was $12 for 1.5 hours. And to get a unit rate, we'll divide each of these by 1.5 or by 1 5/10. 12 divided by 1.5, that equals 8. So we get 8/1. And for our last set of data, for 2 hours, it was $16. $16 for 2 hours. Divide each number by 2 to get the unit rate, and that gives you 8/1. So once again, if I look at my unit rates in each example, I got the same number every time. So the relationship between the cost and the hours rented is proportional. B, state the unit rate and the constant of proportionality for this example. So in each case, when we simplified these down, this 8/1 means it was $8 per hour. That is your unit rate, $8 per hour. The constant of proportionality K in this example, every time we simplified down to a unit rate, we got 8/1, which again is the same as just saying 8. K equals 8/1 or 8. Question 6 wants to know which bicycle store charges more per hour. So here at Pedal Rentals, we can see that it's $8 per hour. If we look back up above at this example, for Supercycles, it was $12 per hour. Again, that was at Supercycles. So it looks like Supercycles is more expensive. So let's go ahead and write that in. Which store charges more per hour? Supercycles charges more per hour. And if I wanted to compare them, I would say that it was by $4 per hour. Okay, 12 minus 8 is 4. Supercycles charges more per hour by $4 per hour.